And then back. And here I go. Naming and identifying solid figures. We've got 16 questions to contend with, so let's get started. So this, I believe, is a pentagonal prism. A triangular-based pyramid, also known as a tetra. Well, we should call it a triangular-based pyramid. Why not tetrahedron? Because we do not know for a fact that their sides are regular triangles, i.e. equilateral triangles. So triangular pyramid, but it does look like a tetrahedron. This here would be an isosceles trapezium prism. A sphere. Notice how they actually indicate that it's a sphere with this dotted line around the middle, this ellipse, how it gives the illusion of depth or 3 dimensions. And here I would call it a square-based prism, but I may be wrong. It's a cuboid, of course, as well. This is a cone. This is a rectangular based pyramid. This is a cylinder. An isosceles trapezium prism again. Square-based pyramid. I recently found out that the more famous pyramids from Egypt are nearly square-based, and it's just astonishing apparently how close they got. Pentagon-based pyramid, or pentagonal pyramid, I guess some people may say. I would just call this literally just call it a cuboid, but they may call it a rectangular prism. Sphere, square-based prism, which is also a kind of cuboid, and a cylinder, and finally rectangle-based pyramid. And we check. Okay, they call that a triangular pyramid instead of a triangle. Pretty much the same. Call that a trapezoidal prism instead of an isosceles trapezoidal prism. Interesting. Square prism. Instead of a square-based prism, they call it a square prism. Cone, rectangular pyramid, cylinder, prism, square-based pyramid. Pentagonal pyramid. All right. Other than that, more or less complete agreement. So it's good. Now, more interest. Finding the volume of each figure, rounding your answer to the nearest tenth as necessary. 14, not bad. So using pi r squared to obtain the base, then we multiply that by 7. So it would be 50, wait, hold on a second. 64 pi is the base, and then times that by 7. 64 times 7 is 448. It's that many cubic kilometers. We've got to have Wolfram Alpha on hand. And we'll be ready. And we obtain, to the nearest tenth, 1,407.4 cubic kilometers. Now, here's the thing. We have right. So it's a hexagonal prism. The apothem is 3.5 feet, and now using the convenient formula of null over 2, which is number of sides times the apothem length times the length of the side, and then divide that by 2. So 6 times, well, we can do 3 times the apothem length, which is 3.5, and then times that by 4, and then times all of that by 3, which is the height. And that should be fine. So we can do that mentally, can't we? What's 4 times 3.5? Will that be 14? And then 14 times 9, 126. So 126 cubic feet. Okay, all good. Cuboid, so real simple, just multiply the lengths of the independent dimensions. So 5 times 6 times 7, which is, well, let's write down how you found it. 210 cubic centimeters. Using NaL over 2, the apothem is 5.5. Can I make sure that I'm actually saying that right? We use 2 sources. No, we use howjsay.com. That's a fantastic pronunciation site. First, I want to get pronunciation correctly. All right, so I'm saying pronunciation correct. And now apothem. Apothem. All right, source 1 says apothem. Source 2, no matches. Source 3, apothem. All right, so I've been saying it wrong the whole time, but that's fine. Apothem, 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 apothem. All right. Henceforth, we're using apothem. So, number of sides times apothem, apothem length times length of the side. So 5 times 5.5 times 8. All of that has to be divided by 2. And then we have to multiply all of that by the height, which is 8. So just do 20 times 5.5. So you'll get 11, and then times that by 10, so 110, and times that by 8, so you get 880, and so it's going to be 880 cubic inches. Here, well, we have a good, it's a right triangle. All right, so it's right triangle base prism. So 3 times 4, that's 12. Half that, that's 6. Times that by 3, and you get 18. 18 cubic feet. Pi r squared, then times pi r squared times h. So the radius is 5, so 25 pi, and then times that by h. So 100 pi. With the nearest tenth is 314.2 cubic inches. And here, they will no doubt start getting a little bit more difficult. So, contend with the trapezium. That's 8, that's 3, and that's 4.3. So, average out the parallel sides, times that by 4.3, and then times that by 4. So, just do 4.3, multiply it by 11 to get 47.3. And then times that by 2. 47.3 times 2 is 94.6. There's that many cubic meters. And now, let's see, this is the right triangle, but it certainly doesn't look it, but it is. So 4 times 3, half it to get 6, and then times that by 5 to get 30, and it's 30 cubic miles. The diameter is 22 feet, so the radius 11 pi using pi r squared, pi, so 121 pi, and then times that by 10, so 1,210 pi cubic, which we should get to the nearest 10. Tenth, 3799.4. Did I do any others in exact form? No, I didn't. Oh. Okay. So, little tiny bit difficult to read this sort of diagram here, but let's say, but I believe that it's saying that the well, let's just say 9 times 6 divided by 2, so 54 over 2, so 27, and then times by 10, so 270 cubic kilometers. I believe, but I'm not sure in this case. A cylinder with a radius of 4 yards and a height of 5 yards. So if it has a radius of 4 yards, do pi r squared. So 16 pi, and then times that by 5 to get 80 pi. 3.14 and times it by 80. $25.12, 25.1320, 251.3, I believe, that many cubic yards. Square prism measuring 6 kilometers along each edge of the base and 5 kilometers tall. So 6 squared times by 5 is 180. A hexagonal prism 5 yards on each edge, and an apothem of length 4.3 yards. So using null over 2, then times that by the height. So 6 times 4.3 times 5, all of that divided by 2, and then times that by 5. So in reality, it's 25 times 3. So 75 times 43, and then divided by all by 10. I think. It is, right? 75. Yeah, roughly that. Okay. A trapezoidal prism of height 6 kilometers. The parallel sides of the base have lengths 5 kilometers and 3 kilometers. So we average them out to get 4. The other sides of the base are each 2 kilometers, and the trapezoid's altitude measures 1.7. All right, so 4 times 1.7 times 6. Six times 1.7 is 10.2, and then times that by 4 to get 40.8. And we're gonna check. We're gonna check everything. Okay, all good. All good. Very nice. And now considering surface area of prisms and cylinders. Not sure what this is asking. I see. Okay. Something like that. We'll do it there. 8.9 is 5, and the side length is 13. 8.9. The height is 8, and the side length is 13. All right, so 5 can go there, quite nice. 16 can go there, and 15 can go there. That's quite a good and agreeable arrangement. That can be 2, and that can be... Wait. That doesn't look like... That, that looks well in excess of it. But, all right. Area and surface area of each figure. So Okay, back 112 pi. About 380 point to the nearest thousandth. All right. 380.133. Now 210. 659.734. And this one, the lateral surface area will be 5 times 7 times 4, so 140 square yards. The entire, you'll need to add on 98, so 238 square yards. Here, for the lateral surface area, the perimeter of the base, so that's 12 times 5, which is 60, and times that by 8, which is 480. That's how many square yards it is. And as for the entire, we need to figure out the area of the base. So for the base, use NAL over 2. So 5 times 8.3 times 12, and then divide all of that by 2. So that'll be 5 times 6, 30. 30 times 8.3, so 249. And then double that to get 498. And then add that on to 480 to get 978. Next up, we have this right triangle prism here. So it's the 3, 4, 5 triangle. I don't know what the actual lateral surface area would be in this case. Well, I guess it would be the 3 sides around the prism, the 3 rectangles around the prism. So that's just going to be, the perimeter all times by 9. So 3, 4, 5, sum them to get 12, times that by 9 to get 108. There you go. And as for the entire thing, 3 times 4 is 12, and then add that on to that, and we get 120. The lateral surface area. I don't actually know what that would be in this case. I guess it would be the non-trapezoidal sides. So, right. Okay, well, that's actually going to be a few things added together then. So 42 plus, I mean, that's essentially a rectangle. So 4 times 6, so 24, and then double that, so 48. And then add on 3 times 6, so 18. 42 and 48 makes 90. Add 18, you get 108. It's that many square yards. And as for the entire thing, now figure out what it is for the trapezoids or trapeziums. So 7 and 3, the average is 5, and then 5 times 3.5 is 17.5, and double that, and you get 35. So add that on to 108, and you get 143 square yards, I believe. Find the lateral and surface area of each figure. Round your answers to the nearest tenth if necessary. A hexagonal prism 6 feet tall with a regular base measuring 9 feet on each edge with an apothem of length 7.8 feet. So for the lateral surface area, it will be, what will that be? 9 times 6 squared. So 36 times 9. So that, I beg your pardon, that should be, shouldn't that be 27 squared? So 729. And for the entire thing, did I do that right? That should be done correctly, not in a rush. So 36 times 9. I want to do 6 times. Again, mistake. By rushing, you make mistakes. Obvious mistakes. Better. Entire thing. So we use null over 2 to get the surface area of the times. Well, hold on now. That's not the upper them. Uh, 27 times 7.8. No, because then it has to be multiplied by 2. by 7.2. $54 times 7.8. $4212. Okay, then add these on to each other. So 745.2. $2 meters tall. The base is a trapezoid whose parallel sides measure 7 meters and 3 meters. The other sides are each 4 meters. The altitude of the trapezoid measures 3.5 meters. So, what does that mean? That means do 7, add 3, add 4, add 4. So we get 18, and then times that by 2. You'll get that. And then for the entire thing, you need to figure out the area of the trapezoids. So 7 and 3 average to get 5, and the height of the trapezoid is 3.5. So multiply that by 5 to get 17.5, and then double it to get 35 to get the top and bottom, and then add that on to get 71. And now check. Everything must be checked. Okay. These are roughly in correspondence. There are multiple possible answers here. Try to do my best to make sure that they don't sort of conflict with one another. Yeah, that's absolutely fine. That's absolutely fine. 96, 144. Okay, so we got the correct figure here, but not here. How is that possible? I mean, I just copied it down. Well, what would the lateral surface area be pi times the diameter and then times by the height. So 112 pi. Why is that not right? Oh my good. It like delivered like the wrong answer somehow. How's that even possible? Somehow, so I can't trust it anymore unless I press enter. Like it's sort of predictive text engine is in error. Or I'm in error. Probably I'm in error. Okay. Oh, they say to the nearest thousandth. All right, 858, that should say. Okay. Continue. Agreement. Correct. That's valid. And the difficult ones, 324. Okay. And cones, shall we? 14 such questions. So I know that for the general cylinder, it's a third of the base area times by the height. The base area is pi r squared, so 4 pi. So 4 pi times 7, 8 pi. And then 28 pi has to be divided by 3. All right. And we get 29.3. Cubic miles. And here, 345 triangle. So the area of the base is, 6. And so that has to be multiplied by 4 and then divided by 3. 6 times 4 is 24 divided by 3 gives us 8 cubic miles. We're going to check these along the way. We're obviously going to check everything, but just these in particular incrementally. 11 times 11 is 121. Times that by 12. 1452, and then divide. Well, if you're going to be dividing by 3, why not just times 121 by 4? So we get 484 cubic centimeters. Here, 2 times 5 times 5, so 50, and then that has to be divided by 3, so 50 over 3. Cubic inches, which is beg your pardon, that's 16 2/3, or for the decimalization. Multiplied by the upper them, multiplied by the length of an individual side, and then divide all of that by 2, and that will give you the base there. And then, okay, so that means 5 times 8.3 times the 12, and then all of that has to be divided by 2 to get the area of the pentagon base. And then you have to times that by 11 and then divide that by 3. So you're not even done yet. So, all right. So that would be reducing that, you're dividing everything by 6, so this 12 can turn into a 2. That pairs with the 5 to turn into 10. And then it's just 8.3 times 11, which is 91.3. And then that has to be multiplied by 10 to get 913 cubic yards. Here, well, it's a regular hexagon, it appears. So 6 times 5.2 times 6. Divide all that by 2. Multiply it by the height, and then divide the final result by 3. So this 9/3 just turns into regular 3. This 6/2 will turn that into 3. So 18 over there. And then 18 times 3 makes 54. So 5.2 times 54. So 280.8, isn't it? And check everything. And that's all valid. Totally fine. So 3, 4, 5, right triangle here. So anyhow, let's get the base. So 48, half that, you get 24. 24 has to be multiplied by 12, but then divided by 3. So you may as well multiply 24 by 4. So you get 96 cubic feet. And here, the base will be 81 pi. 81 pi has to then be multiplied. 81 pi has to then be multiplied by 6. 486 pi cubic miles. So 1526.8. That. Okay, so number of sides multiplied by apothem multiplied by the length of a side. All that divided by 2, multiplied by the height, and then divide all of that by 3. So we get, is there any cancellation possibility here? Well, that can turn into a nice 3.1. That can turn into a 3. 3 times 7, that creates 21. 21 times 5 is 105. So 3.1 times 105. And what do you make that out to be? 3255 cubic yards, I believe. Next up, 6 times 7 times 9, but all of that has to be divided by 3. So 6 times 7 times 3, so 42 times 3, which is 126. And now some worded versions. A square pyramid measuring 10 yards along each edge of the base with a height of 6 yards. Okay, so it had to have a 100 square yard base, times that by the height, giving us 600 cubic yards, and divide all that by 3 to give us 200 cubic yards. Pyramid 5 meters tall with a right triangle for a base with side lengths 6, 8, and 10. So, area of the base, that would be 6 times 8 divided by 2, which is 24, and then that 24 has to be multiplied by 5, Then you have to divide it all by 3. So just do 8 times 5 to get 40 cubic meters. A cone with a radius 4 meters and a height of 12 meters. So the area of the base of the cone is pi r squared, so 16 pi. 16 pi has to be multiplied by 12 and then divided by 3. So 16 pi times 4, which is 64 pi cubic meters. Then that has to be multiplied by 3.14. So it's going to be around 200. And we get around 201.1. A hexagonal pyramid, 11 foot tall, with a regular base measuring 6 foot on each side and an apothem of length 5.2 feet. So 6 times 5.2 times 6, divide all that by 2, multiply that by 11, and divide all that by 3 to get the final volume. That 6 and 2 turn into a 3. That 6 and 3 turn into a 2. The 3 and the 2 combine to create 6. The 6 and the 11 combine to make 66. 66 times 52. So 66 times 52. 3452. That many cubic feet. And now we check everything. Correct. Oh, no, that's not right. Fine. Do that again. 3 times 2, that's 6. So 66. So 66 times 52. Come on, do it right. 3432. Better. Right. That ends this one. So be well, be well.